here, if you want to calculate x1, is going to be a plus delta x, and you guys will get your x1. Just you guys can see it from the picture. If you take a, so this is your a, this distance up to here. And if you calculate a plus delta x, is going to be x1. A plus 2 delta x going to be your x2. x2 going to be a plus 2 delta x. And as you know, x3 going to be a plus 3 delta x. And the pattern going to be exactly what you guys have here. So you can see here, when I equal to 0, x is going to be exactly equal to a plus 0 going to be a. Exactly what we said here. And when I equal to 1, your x1 going to be a plus delta x. I equal to 2, you get a plus 2 delta x, and so on. So up to here, this is similar to what we did, you know. It is similar to what we did last week. Now, the new thing here is, from each of these subinterval, we were going to pick a number called xi star. You guys can see here, xi star, this number is obtained from this interval. So it means when I equal to 0, when I equal to 1, sorry, you will get the first subinterval, which is equal to x0, x1. And you will pick there the x1 star. I'm just going to change the color here. So for example, from this subinterval, you're going to pick a number, and that number is x1 star. Okay, so this number should be only in this interval. So it means it could be the endpoint, or this endpoint, or could be any number inside this interval. So from the second interval, you pick another number called x2 star. It's just a simple point from the second subinterval. From this one, you pick another number, and that number we call it x3 star, and so on. It means from the n subintervals, for each of them, you just want to pick one value. Okay, and by doing so, we're going to define our definite integral as follows. So integral, as you know, going to be just in this notation along s, from a to b, because we integrate from a to b, and f of x. This is a definite integral, the notation for the definite integral, but its value, in fact, is equal to the following limit. Is going to be the limit when n goes to infinity. So n is going to infinity, and you calculate the limit of this sum, which is like similar to the sum that we've seen last week, the sum when I is going from 1 to n, f of f at xi star. And I told you how the xi star was obtained. Delta x, and we already know what is delta x. So if this limit now exists, that value is what we call the definite integral. And we can conclude, you know, that, you know, the function f is integrable over the interval ab. If the limit does not exist, it means the function is not integrable. Okay, so this is, you know, the definition of definite integral. It means anytime you guys get a question asking you to calculate a definite integral by using the definition, so you have to use exactly what I explained here. And to do so, you have to name your endpoint and find all these xi star, delta x, and you substitute by their values, and after that you calculate the limit. If you get a number, it means that number going to be your integral. If you don't get a number, or, you know, the limit does not exist, it means the function is not integrable over the interval ab. Okay, any question?
Sir, I do not understand the part where it says that xi star lies in the ith interval from xi minus 1 to xi. So why did we get the -1 from?
No, it's just a notation to list all intervals. Because here, if we subtract, because the I are going from 1 to n. If I equal to 1, so you will get I equal to 1 gonna give you your first interval is going to subtract I by 1. You will get here 1 minus 1. So the 1 is here, the index. It's not xi minus 1. It's some I minus 1 here. So you will get here x 0 when you substitute and x1. Okay?
Yes, all right.
Okay, it's not like that. It's not xi minus 1. It's not that. Be careful. Okay?
Yes, I got it.
Maybe you thought it was this. Hello? Your mic, please. All right. So the -1 is part of the index, the subscript, okay? So when I equal to 1, you will get x0, x1. I equal to 2, you will get x1, x2, and so on. And from each subinterval now, we're going to pick a number called xi star. So from the first subinterval, we're going to pick the number x1 star. From the second one, we're going to pick the number called x2 star, and so on. Any question? All right. I'm going to erase this. And that's what I mentioned here, exactly what I explained before. The integral is equal to the limit of this sum when n goes to positive infinity. If the limit exists, the function is integrable and its value or the value of the integral going to be exactly equal to the value taken by this limit. If the limit does not exist, the function is not integrable. Sounds good? So next, I'm going to give you some properties, and then we'll see how to apply the definitions here in order to find a definite integral. First remark here is the sum that we use in the definition. This sum is called a Riemann sum. So Riemann is just a German mathematician who first proposed this way to define the definite integral. That's why we call this sum the Riemann sum. It's just a German mathematician. And if, for example, now the limit of this sum exists, as I told you, if the limit equal to a number, we conclude the function is integrable on the interval AB. So basically, it means anytime you guys hear this function is integrable on the interval AB, it means when you calculate the limit that we've seen in the previous slide, you're supposed to get a number. So that number could be 0, could be negative, could be positive, doesn't matter. Integrable means the limit gonna be equal to a number. And second remark here, third one, sorry, there is a connection between calculating an integral and calculating the area of the region bounded by a curve of a function, the x-axis, and one axis between A and B. Just be careful. A lot of students think calculating the integral is exactly equal to calculating area. No. They coincide under some condition, otherwise they're going to be different. And the condition is the function should be positive over the interval AB. Otherwise, the integral is not necessarily equal to that area. I'm just going to make a picture and you guys can see exactly what I'm saying. So let's say you guys have here the x-axis And we have here the y-axis. And we have here, for example, let's say A and the interval B, AB. And I'm going to draw here the curve of this function. So for example, this is my function f. And we would like to calculate the area of the region bounded by the curve of f, the x-axis, and when I calculate this area. Okay, so this function is positive. That's why the curve is above the x-axis. If the curve is not positive, the curve is going to be below the x-axis. Okay. In this case, the area is equal to only this condition, because the function is positive. The area is going to be exactly equal to integral from a to b of f of x. Dx. And the reason why the area is going to be equal to the integral, because your function is positive, and the definition says your xi star could be any number from the interval xi minus 1 xi. Okay, so in this case here, f of x is positive. F of x is greater than 0 over the interval AB. Okay, now that's exactly the meaning of what I said here in the remark C. But if, for example, now the function is not positive, the area and the integral gonna be different. Okay, so for example, let's say here, in this case, you guys have this function, which is a negative in this case. So in this case, my function f is negative. So means f is less than 0 for x belonging to the interval AB, because we are interested in that interval. So if the function is negative, it means graphically the curve going to be below the x-axis. You guys can get something like that. All right, so this is my function f. It's below the x-axis. That's why we can say it's a negative over the interval AB. Okay, and in this case, the area bounded by the curve, the x-axis, just going to change the color. So this area in this case is not exactly equal to the integral. So in this case, the area is going to be equal to, so since my function is negative in this case, when you calculate the integral, you will get a negative number. And this is just obtained from this formula, because my delta x is always positive. It's the width of your interval, is the length, cannot be positive, negative. And my f, since my function f is negative, it means this f, all these f going to be negative. That's why the integral going to be also negative. So that's why I said here, if my function is negative, the integral going to be negative. So when you calculate the integral from a to b, you will get a negative number. And that negative number going to be the opposite of the area. They're going to be equal in terms of absolute value, but they're going to be opposite each other. So that's why I have to add a negative sign in order to make it positive. Without the negative sign, your integral is going to be negative. You add the negative sign in order to make it positive. Just keep it in mind. Anytime you guys get a question asking you to find the area, so you can use the integral to calculate the area, but first you need to know what is the sign of f over the interval AB. So if you realize, the function is positive in the entire interval, in that case, the area going to be exactly equal to the integral. If, for example, the function is negative, the area going to be the opposite of the integral. So it means you calculate the integral and you multiply it by -1 in order to get the area. Okay. So this is part C is, the first graph or the first picture is explanation of part C, and part D gonna be exactly what I explained here on the right hand side of your screen. Okay, so I'm gonna remove this and be careful now. You can get a third case, for example, where your function is just positive in one part of the interval AB and negative in the other part. In that case, you have to split your integral into integrals in order to get the exact value of the area. So let's suppose here you guys have A and B, and the curve look like this. In this case, the area you guys can see between, I'm going to call this point the x intercept, I'm going to call it C. So you guys can see between A and C, the curve is below the x-axis. It means the curve is negative, the function, sorry. And between C and B, the curve is above the x-axis. So it means the function is positive. So that's what I mean, by saying the sign or the function changes over the interval AB. In this case, if you guys want to calculate this area, if you want to calculate this area here, bounded by the x-axis, the curve when A is between when x is between A and B. So in this case, you guys have to split it into integrals. Between A and C, the function is negative. You have to apply this, what I said here on the left hand side. And between C and B, you apply, sorry, between A and C, you apply what I said here on the right, because on the right, the function is negative. So that's exactly what happened between A and C. You apply what I said about, this curve on the right hand side of your screen. And when C is between, when we consider interval CB, we apply what I said, on the left corner here, bottom of your screen. So you have to split it in this case into integrals. You calculate the integral from A to C, and in that case you apply the fact that the function is negative, and between C and B, the function is positive. You apply exactly what I said about the positive function. Any question? All right. And that's what I said here for the last, remark here. If your function is negative, so the curve is going to be below the x-axis. In that case, the area that we're looking for going to be equal to the opposite of the definite integral. I just gave you this remark, to let you know the area is not exactly or is not always equal to integral. They are equal for positive function. Otherwise, the area is going to be different to the integral. All right. So now this is the remark I gave you. So next, I'm going to give you some result that's going to help us to pick the right xi star in order to simplify our calculations when it comes time to calculate a definite integral. And they are given by these two formulas. So the first one says if my function f is continuous over the interval ab, or if it's discontinuous, at some point, a finite number of point, in that case, the function is going to be always integrable. So basically, it means any continuous function is automatically integrable. And any discontinuous function with a finite number of discontinuity going to be also integrable. Just want to make a picture and guys can see exactly what the term says here. For continuity, basically it means you can sketch the graph without skipping any point over the interval that you consider. So if I consider this interval AB, and let's say in this interval my function is continuous, it means I can sketch my curve without skipping any point in the interval AB. Let's say this. Such function is always integrable over the interval AB. That's the meaning of this term. If your function f is continuous over the interval AB, is going to be integrable on that interval. Now for the discontinuity case, it's look like this. For the first case here, the function is continuous. That's why it's integrable. It means if you calculate the limit, you will get a number. But for discontinuity function, the number of discontinuity should be finite. So for example, let's say here is my A, and I have my B here, and my function look like this, is not continuous here. For example, at this point is not continuous. And I have another point here where the function is not continuous. And I have another function here, another point where it is not continuous. And after the function look like this. So you guys can see this function is not continuous at this point. I'm going to call it C1. The second point where is not continuous, I'm going to call it C2. And the third point where it's not continuous, I'm going to call it C3. And you guys can see here, we have finite number of discontinuity. Such function is also integrable. That's the meaning of this term. For these two cases, the function is always integrable, because for the second one, we have a finite number of discontinuity. In my example, we only have 3. Okay, and it's the jump discontinuity, because you guys can hear up to here, you this big jump go up here, and you have to do a big jump to continue. That's why we call this kind of point, a jump of discontinuity. But there should be a finite number in order to get a function which is integrable. Okay, so basically it means anytime you guys realize your function is continuous on the interval AB, automatically you can say that function going to be integrable and you don't have to prove it. If your function is discontinuous, but the number of discontinuity point is finite, you can also conclude that function is integrable. Any question?
Okay. So how will I know if it is finite or not?
So you check here, or from the domain, you check just inside the interval. So for example, if you have, you need to know exactly what kind of function you have, and you check, so you can sketch the graph to see it, or you can check, if there is any point where the function is not defined. Okay, and for such function you check. This is going to happen, for example, when you guys have a piecewise function. So you have to check the breakpoint, all breakpoint. If your function has two pieces, so you will get just one breakpoint, and you check your breakpoint. If your function has, let's say, three pieces, you will get two breakpoint. You have to check the two breakpoint if the function is continuous or not. Okay, it depends on the kind of function that you guys have. Okay, so piecewise function, so you have to check just the breakpoint. So it means, the point where the equation of the function changes. Is it okay?
Sir, how will I check the breakpoints?
So breakpoint means here, if you have, for example, let's say f of x is equal to a piecewise function equal to 2x if x is less than -1. So it means, oops, less than -1 and equal to x squared plus 1. For example, if x, let's say, if I'm going to just, if let's say I'm going to take -1 here. If x is between -1 and 3, for example, and we have here, let's say, e to the power x if x is greater than 3. This is a piecewise function, and we have three pieces, and the breakpoint are -1 and 3. Okay, so when x is less than 3, this is just a linear function, it's always continuous. When x is between -1 and 3, this is a quadratic function, which is always continuous, because you guys know a polynomial function is always continuous. And when x is greater than 3, you get exponential function, and exponential function is always continuous. It means if these three conditions are satisfied, your function is going to be continuous. Now, your problem is going to be at -1 at 3. Is it continuous or not? You check. If it's continuous, it means the function is integrable. If it's not continuous, doesn't matter, because in this case, you will get a finite number of discontinuity. So you can say, okay, it's not continuous at -1, at 3. That's it. For the other values, going to be continuous. And again, it's still, integrable. So this is what I mean by the breakpoint is the point or the value where the formula of f changes. So the formula of f changes from 2x to x squared plus 1 at -1. Before -1, it's 2x. Right after -1, it becomes this formula, and less than 3. But after 3, the function becomes this. And all of them are continuous in the specify interval. But at the breakpoint, we have to check if we have something like that, a big jump, or it's continuous. And it's going to be a finite number of discontinuity and also still integrable. Is it okay? Hello? Are you still here?
Yes, sir.
Is it good?
Hello,
Yeah.
sir.
Yeah.
Sir, I have a question.
Yeah.
Sorry, if we are supposed to find an area from A to C1 or A to C2, can we find it?
Yeah. So you have to
From
split it into,
sir, if we need to find suppose from A to C2, so
yeah.
can we find the area using integration from using
Yeah.
the integral A and C2?
Yeah. So you have to
But
split
sir,
it.
there is a breaking point there.
Yeah. Doesn't matter. The function is here. The value taken by f is here at C1. You have a hole. It means at C1, the value taken by f is this. That's why we have a dot. Is this value corresponding to this value here? It's not the value corresponding to the hole. That's the meaning of this dot. Now, if you want to calculate the area, it's not big deal. You have to split it into areas. That's it. You will get an area here, the green one. You calculate it first by using integral. You integrate from A to C1 and plus now the other integral. So plus, you take this one. In this case, you cannot calculate as just one integral. You have to use two integrals. You integrate from A to C1 first, plus the integral from C1 to C2, and you're done. So you have to add
So
the two
thank you,
areas.
sir. I got it.
Thank you. All right. Now, next theorem. So this theorem says if your function is already integrable on the interval AB, in that case, calculating the integral becomes just calculating this limit. You guys can see this is different to what the definition says. The definition says the integral from, so the integral from A to B based on what we did before at the beginning. So of f of x dx, so we've seen this is equal to the limit. So this is equal to the limit when n goes to infinity of the sum of f at xi star. That's what we said at the beginning when we was defining a definite integral. Delta x when I goes from 1 to n. I is going from 1 to n. And you guys can see they are very close, but the difference here is instead of xi star now, we have xi. And the reason here is the definition says, you know, if you want to calculate this, you can pick your xi star from x from this interval. So back to our definition, you guys can see it here. As I told you, you guys can see here the where the xi is from, the xi star. The xi star, you guys see, is from this interval. So it means the xi star could be any number from this interval. And at the end of the day, you will get the same solution if the function is integrable. So it means the integral does not depend on how you choose your xi. The only condition is the xi should be from here, this interval, that's it. Is it, the smallest endpoint or the largest endpoint or the midpoint or any other point inside the interval does not change anything. If your function is integrable, you can choose any number from this interval and the limit gonna returns you the same value no matter what is xi star. As soon as it's from this interval, that's good. And that's exactly the meaning of what I said here. That's why my hypothesis in this case is, I suppose my function is already integrable on the interval AB, and in that case, you can choose your xi star from the interval, by taking any number from that interval. And to simplify my calculations, instead of taking the midpoint of that interval, I'm going to take just the largest endpoint. It's going to simplify a lot my calculation. You can take just one of the endpoint, but I've decided to take, the largest endpoint. That's it. And now it means anytime you guys know your function is integrable, calculating the integral, you can decide to pick, instead of taking your xi star, from the interval by using any kind of formula, you can simplify your calculation by just taking your xi, and gonna be easier for you to do the calculations. But if you want to do it complicated, you can take, the midpoint too, but the formula going to be more complex. But at the end of the day, you will get the same solution. Okay? But how to know now at the beginning, my function is integrable without calculating the limit? It's given by this theorem. That's why we need to combine these two theorems. Knowing my function is continuous, it means my function is integrable. And based on that, now I have the right to substitute my xi star with xi and do my calculations. And I'm supposed to get a number since my function is already integrable. Okay? And this is, what we're going to use next in order to calculate the definite integral by using the definition of definite integral. Is it okay? All right. Now let's see how to use it. You guys can see here's what the question says. Would like to calculate this definite integral, and based on what you did in high school and in 1500, I know you guys can calculate this one really fast, easily. But the question mentioned to use the definition of definite integral. It means, so if you use the technique that you did in 1500, so you will not get any mark for that, because this question mentioned here to use the definition of the definite integral. Okay, so let's now see how to do it. All right. So here is our function is here. So just keep in mind, would like to get here this integral. And I start by setting here this polynomial function as f of x. I call it f of x now. Okay, that's why I started here. Oops. It's gonna, all right, so I let here f of x equal to negative x squared plus 3x minus 2. This is the function given by the question that we're supposed to integrate over the interval -3, 1, given also by the question. And as the question mentioned, we have to use the definite integral. That's why I'm just going to remind you here what is exactly the definition of the definite integral. So integrating from -3 to 1 is equal to calculating this limit when n goes to infinity. So here n is going to infinity. That's exactly what the formula says, not x. So we calculate this limit when n goes to infinity of this Riemann sum. Now we need to identify our xi star and substitute by its value, and delta x we substitute by its value in order to be able to calculate the limit. And as we know, delta x is equal to the width of the subintervals, and the formula says it's equal to b minus a over n. We consider this interval, we integrate from -3 to 1. So it means a gonna be -3 and b gonna be 1. And the formula says delta x equal to b minus a over n. That's what we saw before. This is a delta x. And in our case, as I said, b is 1 minus -3 is a. When you calculate, you will get 4 over n. And as you know, delta x is the width of the subinterval. It should be positive. If you get a delta x which is negative, you will be penalized because it means you don't know exactly what you're doing. The width of a subinterval cannot be negative. So be careful. Okay? It's going to be the largest endpoint minus the smallest one, and you divide by n. So done. So the first part of this formula here is obtained. Now we need to get xi star. But the formula says xi star is any simple point from this interval. So I wrote here 1. It's any simple point from this interval. So it means I can pick any number from here. But I don't want to, I just want to simplify my calculation. That's why I'm going to use what the term says here. I want to use term number 4 and 5. And what term 4 says is my function is continuous. Why? Because it's a polynomial function, 1500. So you guys have seen in 1500, any polynomial function is continuous. That's what I use. And based on what the term 4 says, any continuous function is also integrable. So I wrote here differentiable, but it's supposed to be integrable. So we're done with this. Just want to change the color, and it's supposed to be here is integrable. Okay, not differentiable. It's just, you know, from here, I just use the combination of 4 and 5. My function is a polynomial function. That's why I conclude it's continuous over this interval, -3, 1. And since it's continuous, it's going to be integrable on the interval AB. And based on theorem 5, since it's integrable, now I can replace my xi star in the formula by xi. I'm explaining here the reason why I'm changing my formula. So that's why if you guys get such question in the quiz or in the test final exam, you need to explain the reason why you're changing the formula. Instead of xi star, you replace it by xi because what I explained here. And we set xi star equal to xi. And you guys can see the initial formula. I repeat it and I substitute xi star by xi. And the 4n is this delta x. We multiply by delta x. I just substitute delta x by its value. And the value of delta x is right here. and I replace by its value in order to get 4 over n. Okay, now we're ready to do the calculations. And from here, I'm gonna substitute inside this bracket here, xi by its value. The value of xi, as we know, is equal to a plus I delta x. That's what the formula says. And we already explained why, and this is my xi. A is -3, as I said before. You guys can see on the top is your a -3 plus I delta x, and I replace delta x by its value. Delta x equal to here. So that's why my xi now is equal to -3 plus 4i over n. So next step, I'm going to calculate the value taken by f at -3 plus 4i over n. And to do so, I have to use the formula or the equation of f. And guys, you know, when you want to calculate f at 100, you substitute here x by 100. Now I'm calculating f at -3 plus 4i over n. So it means in the formula of f, I have to substitute any x by -3 plus 4i over n. And doing so, I'll get these square brackets. You guys can see here, when from the first term, you substitute this x by -3 plus 4i over n, so you will get this term. This is your x, you square it. Plus 3 times x, you substitute, you know, x by this term again from the second term. And the last term is -2. And outside the square bracket, this is my delta x. I just copy it from here. Now I'm going to expand the first bracket, and doing so, and taking into account, you know, the negative sign in front of this bracket. So I'll get -9 plus 24i over n minus 16i squared over n squared. And I'm going to open the second bracket, and it becomes -9 plus 12i over n, and just copy the last term. Okay? Any question before I move to the next page? All right. Okay. Now, from the next page, by adding these values, what I did here is, you guys can see we have -9 and -9 going to be -18, -2 going to be -20. That's what I got here. That's why I got inside my bracket -20. And for the second term is obtained from here. I have here 24i over n plus 12i over n is going to be 36i over n. And I just copy this as the last term. Okay, 16 minus 16i squared over n squared. Okay, I'll let you take this the solution right here before going to the next page. And you guys can tell me whenever you're done. Are you done with this? Yeah or no?
No.
No? Okay. Okay, Navid Sams. Go ahead, Navid.
So before the last equation, did you use a plus b whole square formula?
Did we use what?
like the minus 3 plus 4i by n whole square. Did you use the a plus b whole square formula?
Yeah,
Oh,
but
okay.
I took into account this negative sign. That's why we have here minus.
Oh, okay. So thank you.
Okay, so without this, it's going to be 9 only instead of minus 9. It's going to be 9 minus 24i squared plus 16i squared over n squared. And I multiply with minus 1. That's why the sign changes for all these trees, these three terms. Is it okay?
Yes, sir.
Okay. Pardon? I didn't get you. Who's speaking? Are you done with this? All right. Now, as I said, I calculate this, going to be minus 9 and minus 9 here, going to be minus 18, minus 2, going to be minus 20. And 24i over n plus 12i over n going to be 36i over n. And last term going to be minus 16i squared over n squared. And don't forget this term outside the bracket. And that's exactly what I got here. Now, I'm going to split it into 3 sigma notations because we've already seen the properties. But before doing so, I'm going to put this 4 over n inside. Multiply. So 4 over n times negative 20 going to be negative 80 over n. 4 over n times 36i over n going to be 144i over n squared. And when you multiply with the last term, you guys get minus 64i squared over n cubed. And you split it into 3 sigma notations, taking, the constant out. And you will get, the second line here. When I took the negative 8 over n out, still have 1 here inside. I took this term out. I have the sum of I from this I. And I take this out, going to be the sum of I squared. The reason why I split it into 3 sigma notations, because I know these formulas based on what we did last week. The sum of 1 is equal to 1 plus 1 plus 1 n times. It's going to be just n. And here's the sum of i's. We know is equal to n times n plus 1 over 2 based on what we did last week. And the sum of the square is equal to n times n plus 1 times 2n plus 1, the whole thing over 6. Now, from here, I'm going to simplify because I'll get indeterminate form when I try to calculate the limit from this step. That's why I need to do some simplification in order to avoid, the indeterminate form. So you guys can see from here, I just simplify by n, and I'll get just minus 80. From the second term, I simplify here first by 2, and I'll get his 72. I simplify n, this n, and 1 n from here. And one is, you will get the numerator going to be 72 times this bracket, and denominator becomes only n. For the last term, you guys have 64 by 6. You can simplify by 2. So here we'll get just 3. And here you simplify by 2 is going to be 32. And so we have here denominator equal to n cubed. And here you have 1 n. I'm going to simplify n here. And one of these 3 n, I'll get n squared now. And that's why we'll get this term. So the first term does not depend on n, is a constant. It's not a big deal to calculate the limit. But the second term going to return as infinity over infinity, which is indeterminate form. Same for the last term. So that's why I'm going to take here n out. I'm going to factor out the n. And If you factor out the n, you guys will get 72n, and the bracket gonna be just 1 plus 1 over n, and I cancel the n here. Same for these two brackets. From the first bracket here, I took one n out. And from the second bracket, I took one n out. And this n times this second, the first n, going to be n squared, and you simplify with this n squared. And now we're ready to calculate the limit, because when you let n approaching to infinity, 1 over n is going to 0. So the bracket going to be 1, and you multiply by 72. That's why we got 72 here. From the last term, when you let n going to infinity, the first bracket is going to 1 plus 0, because this term is going to 0 when n goes to infinity. The second term is going to 2 plus 0. So it means the numerator is going to be 2 times 32, which is equal to 64. And denominator is still equal to 3. And after calculation, you guys will get negative 88 by 3. And since we got a number, it means my function f is integrable over the interval negative 3, 1. And its definite integral is equal to minus 88 by 3. Any question? Okay, guys, give us a second. I'll let you write down this.
Sir,
Yeah, give us a second. Yes. What was your question? Hello?
yes, sir.
Yeah, I didn't get you.
Sir, I got you. No problem.
Pardon?
So yeah, I got the math, so no problem.
Okay. Okay, so if there is no question, we're gonna move to the next part. All right, just keep in mind, based on what we did here, if you guys have any question asking you to calculate a definite integral by using the definition of a definite integral, You guys have to use the step that we use to calculate this one. So the long way. If the question does not mention this part here, for example, if the question does not mention this, so you guys can use the FTC that you did in 1500, and that's exactly what I'm going to remind you next, and we'll see again how to apply it. So here is the FTC, the fundamental theorem of calculus. And what the term says is if your function is continuous, and based on the term 4 and 5 that we've seen before, the continuity is very important in this case. As you can see here, I told you from 4, when my function is continuous, is going to be integrable. Okay, so that's why in this case here, if my function is continuous on the interval a, b, for sure it's integrable, and calculating, you know, the definite integral in this case, gonna be exactly calculating the value taken by capital F at B minus the value taken by capital F at A, where capital F is an antiderivative of this small f here. So basically it means when you guys want to calculate the definite integral, if the question did not, you know, ask you to use the definition of definite integral, so you guys can use this one. It's going to be faster and easier than using what we did before. Okay? If the question doesn't mention anything, use this technique. Don't use the first one. And the antiderivative, you guys did it in 1500. I will not spend time on it. So you find an antiderivative and you evaluate it at B, the top, minus its value at A, and you get your definite integral. In this case, it's going to be for sure a number because your function is continuous. And we've seen any continuous function on a closed interval going to be integrable on that interval. So that's why for sure you'll get a number. If you use the limit method, you'll get the same thing. So next we'll do some example, and the first example is right here, integral from 1 to 4, root of x dx. All right, so here is our integral. We integrate root of x from 1 to 4. And here we're going to use, you know, the FTC. And before using the FTC, we're going to write our function as a power function, and we'll get x to the power half. And the antiderivative of x to the power half is going to be x to the power 3 by 2 over 3 by 2. How to get the 3 by 2? So from the exponent here, you guys add 1. And you divide by the new exponent. Because when you add 1, the new exponent is going to be 3 by 2. And you divide by the same thing. And you guys can see here, this is an antiderivative because when you differentiate it, you will get x to the power half. Okay? And you evaluate it at 4 and at 1. And before doing so, I'm just going to simplify the denominator because guys know when you divide by a fraction, it's going to be multiplying by the inverse of the fraction. That's what I did here. And when I evaluate this function at 4, so I'll get this first term, we substitute x by 4, minus its value at 1, as the FTC says. So we'll get just 2 by 3 and 1 to the power 3 by 2. And keep in mind here, 4 to the power 3 by 2 means root of 4 to the power 3. That's why we got 8 here. And after calculation, you guys will get 14 by 3. And this is, you know, the definite integral of this function on the interval 1, 4. Any question?
No problem. It's okay.
Sounds good?
Yeah.
All right, thank you. Are you done taking this, the solution? So you guys are done with this page? All right, so let's move on to the next example. All right, so next example, as you can see here. So we want to integrate again same interval from 1 to 4 and 1/4. And what is the antiderivative of 1/4? You guys remember?
ln x.
Exactly, it's going to be ln of absolute value of x. Okay, so don't forget the absolute value because you don't know if the x is positive or not. In this case, it's going to be positive because x is between 1 and 4. Okay, as your friend said, the antiderivative of 1x is ln of x, and you take it at 4 and at 1, it's going to be ln of 4 minus ln of 1, and you guys know ln of 1 is 0. That's why solution is going to be ln of 4. We drop the absolute value because absolute of 4 is exactly equal to 4, and you're done. Any question regarding example 2? Example 4, question 2.
No, sir. Thank you.
All right. All right, so next I'm going to give you some properties of the definite integral. Okay, so we here suppose that, you know, we have two functions and both of them are continuous, and based on what theorem 4 says, it means these two functions are integrable on the interval AB. In that case, calculating the integral of k times f, where k is a constant, is exactly equal to k times integral of f. So it means we can take k out of the integral because we're integrating with respect to x, and k does not depend on x. That's why we can take it out of the integral. Second case, when you integrate a constant, any constant, is going to be k times b minus a. So if you guys keep in mind this formula, so you don't need to do the calculation. But otherwise, doing the calculation, so antiderivative, what is an antiderivative of k? You guys can tell me?
So 1.
K square? No.
Sir, it's a constant.
Pardon?
K is constant.
K square?
No, sir, it is a constant value, so it will remain as it is.
But what is the antiderivative?
A square by 2.
No.
So it's 1.
No.
So it's kx.
Kx, exactly. K is a constant. Which function has its derivative equal to k? It's k times x. If I ask you to find integral from 1 to 5 of 3, so which function has its derivative equal to 3?
3x.
3x?
Yeah.
Sorry, it is just 3x. K is a constant. As you can see here, it's like any number. So it's going to be 3 times x. And when you evaluate it at 1 and at 5, it's going to be just 3 times 5 minus
12.
3,
Minus 3.
and you will get and that's exactly what the formula said. You see, you don't need to do all this calculation, what I did. If you keep in mind this, anytime you integrate a constant, it's going to be the constant times the width of the interval of integration. It's going to be just the top minus the bottom times k. And that's exactly what I did. Top minus bottom times k equal to 3. So we'll get 12 in this case. So for example, if someone keep in mind this, just from here, you can say this is equal to 3 times 4, which is equal to 12. So this is the meaning of this second property here. And for the third one, integral from a to a is always equal to 0, because here we reduce the interval of integration to 1 point. No matter what is f, when you integrate from a to a, so you'll get 0. You don't need to do the calculations. If you do it, so you will get 0 too. So for example, let's say from one something like that, if I say integral from 2 to 2 of x cubed, automatically I can say is equal to 0. But if you don't realize, this is 0, if you calculate it, you will get 0 too, because you will get here x to the power 4 over 4, and you take it at 2 and at 2. So you will get here 2 to the power 4 going to be 16 over 4 minus at 4 again, at 2 again going to be 16 over 4. And you will get 0. It's going to be just wasting time by calculating this. But if you realize you guys have integral from a to a, just keep in mind. So regardless what is f, so we'll get 0. Okay. So next property is when you integrate from b to a, and for some reason you guys need to switch the two bounds of the limit. So you have to multiply by -1 in order to keep the same value, because integrating from b to a means you guys going from b to a, that direction. And here, this one is going from a to b, two opposite direction. In order to stay in the same direction, you guys have to multiply by -1 in order to get the same direction. Just keep it in mind, anytime you switch the bound of your integrals, the bounds of your integral, you guys have to multiply by -1 in order to get the exact same value. Otherwise, you will get the opposite of the right answer. Is it okay? All right, next property is, again, same thing. We still have our two functions continuous, means integrable. And the fifth property says, the integral of a sum is equal to the sum of integrals. And the integral of a difference is also equal to the difference of integrals. Okay. It means when you guys want to integrate a summation of function, you have to integrate term by term. So here you have two terms. So you have to integrate, term by, if you get more than two terms, you have to integrate each of the terms. Now, calculating integral from a to c and integral from c to b is going to be just integral from a to b. So you combine the two integrals into one integral, because here the top is equal to the bottom. You start from a, go up to c, and from there you go to b. It means it's same as going from a to b. And for the next one, I already mentioned it. If my function is positive on the interval a, b, the integral of f gonna be positive. That's what I told you. And in that case, gonna be equal to the area of the region bounded by the curve, the x-axis, and the vertical line AB. So basically it means the integral of a positive function is equal to a positive number. And from here, we can, draw integral of a negative number, also going to be a negative function, sorry, going to be also a negative number based on what we got here. If you integrate a positive function, you will get a positive number. If you integrate a negative function, so you will get a negative number. So next property here is, if f is greater or equal to g for all x belonging to the interval AB, so the integral of f going to be also greater than the integral of g. Basically, it means the integral keeps the inequalities. As soon as x is greater than g, the integral of f going to be also greater than integral of g. And if, for example, now you guys have f of x, which is between m and capital M for all x belonging to the interval AB. So capital M, for example, could be the maximum value. You guys have seen how to find maximum value in 1500. And the small m could be, for example, the minimum value. So if f of x is between capital M and the small m, so the integral of capital F going to be between these two values, m minus b times b minus a. Just keep in mind this is just equal to integral of m. And the value on the right is equal to integral of capital M over the interval AB. So it means you can squeeze, the value of this integral between these two values, knowing m and capital M. And you can take the mean value of these two values as an approximation of the integral. So this is used sometimes when you guys have very complex integral that you cannot calculate. You can squeeze it between two values and take the mean value as an approximation. And to find these two values, we have just to find the maximum and the minimum. Values taken by the function. Any question?
No, sir.
Okay. So next I'm going to do some examples, in order to apply the properties that we've seen so far. So I'm going to do example number 5. All right, for example number 5, we're integrating here from 3 to 4. And the numerator is equal to x squared minus 1 all squared. And the denominator is x squared. And you guys can see this function looks complicated. We don't know exactly the antiderivative. That's why we will try to simplify it first. And to do so, we're going to expand the numerator and we'll get x to the power 4 minus 2x plus 1. So the denominator is still equal to x squared. And we can simplify. So x to the power 4 by x squared going to be x squared. X to the power, so this x squared and this one cancel out, we'll get 2. And the last term becomes 1 over x squared. Okay? Now we can integrate term by term exactly what the property says. You integrate the first term here is going to be x cubed by 3. So you integrate negative 2 and integrating a constant, you guys know you're gonna be just 2x as the antiderivative, and the antiderivative of 1 over x is equal to -1 over x. And when you calculate the value taken by the antiderivative at 4, you guys will get the first bracket, and the second bracket is the value taken by capital F, this function, at 3. And to conclude, we have to calculate, this, drop the two, drop the brackets and do the calculations. Any question?
So from the simplification, how did you get -2x squared?
How to get this -2?
From the simplification.
Here?
Yeah.
Now expand this part. I just use this formula to expand it. If you guys have a minus b, so the formula is equal to a squared minus 2ab plus b squared, right? And in our example, a is equal to x squared. That's why I have x to the square is squared going to be x to the power 4, and 2ab going to be 2 times x squared times the -1. We'll get minus 2x squared, and this one is squared to get the b squared here. Is it okay?
Yeah, thank you.
Okay. Now, if you drop the brackets, just keep in mind here we have 9 minus 3 going to be 9 minus 6 going to be 3, and here we have minus going to be -3 plus 1 over 3. So that's what I did here. When it drops the brackets, and then we'll get 64 by 3 plus 1 over 3. That's why we got here 65 by 3. And -8 minus 3 gonna be -11. And we have 1 over 4 here. And after calculating, it's gonna be 6 here. Oops. It's 136 by 12. Any question?
Nope.
Thank you. All right, so next example, it's an integral from 0 to pi by 4 cosine of x. Okay, and to calculate this one too, we're going to use exactly what the FTC says. Oops. Out here. So the integral going to be 3 times, as the property says here, 3 is a kf. So you integrate only the function and you multiply by 3. That's exactly what the property says, the first one. So it's going to be 3 times the integral or antiderivative of cosine is sine, and you take it at pi by 4 and at 0, so you get this line. And sine of 0, as we know, is equal to 0. Sine of pi over 4 is equal to root 2 over 2. Okay, so the second term is already equal to 0. Any question?
Nope, not good.
All right, thank you. All right, so one more example. Now we want to get the definite integral of x times absolute value of x plus 1. So in order to calculate this integral, we need first to drop the absolute value. That's what we need. And to drop the absolute value, you need to know the sign of x plus 1. Because you guys know if x plus 1 is positive, the absolute value gonna return you the same thing. If x is negative, the absolute value gonna make it positive by multiply by -1. Example, as you know, absolute value of 3, you guys know this is equal to 3 because 3 is positive. But if you calculate absolute value of -3, since the -3 is negative and absolute value is supposed to return as a positive number, absolute value going to multiply it with -1. And it becomes, oops. And this is equal to 3. Because absolute value is always, has always returns as, you know, a positive number. If you put in a positive number inside, the return is the same thing. If you just put a negative number, it's gonna multiply with -1 and returns you the positive part. So that's why we need to know what is the sign of x plus 1 in order to know how to drop the absolute value. And to do so, you guys can see here, x plus 1 is positive because we would like to know where it's positive, because if it's positive, it's going to return as the same thing. And we don't know exactly where x plus 1 is positive. That's why we're solving these inequalities. So for this inequality, x plus 1 is positive when x is greater than -1. And it means if you guys have -1 here, so x plus 1 going to be positive here. On this side, x plus 1 is positive. That's what we have here. When x is greater than -1, so x1 plus 1 positive. But what it means, you know, if this condition is unsatisfied, x is going to be negative. So it means when x is less than -1, it's going to be negative here. And now we have to compare or to locate, you know, -1 with respect to our integral interval of integration. You guys can see here, -2 going to be here. And we have 1. So we're integrating from -2 to 1. And you guys can see here, this at this point, the sign of x plus 1 changes. That's why we have to split it into integrals. We integrate from -2 to -1. And we add the integral from -1 to 1. Because the sign is different based on where x is. If x is between -2 and -1, x plus 1 going to be negative. But if x is between -1 and 1, x plus 1 going to be positive. Okay. And that's what I use here to solve, this example. So you guys can see here, x plus was as I did, before. You split it into integrals. You integrate from -2 to -1, and I gave you the reason. And integral from -1 to 1 for the same function. And in this interval, we already know between -2 and -1, x plus 1 is negative. So the absolute value going to make it positive by multiplying with -1. That's why we have the negative sign here. We multiply this -1 with this bracket in order to make it positive. For the second interval, -1, 1, it's already positive. We drop the absolute value without making any change. And now we need to expand the two brackets. From the first integral, the brackets becomes minus x squared minus x. And from the second bracket, you guys get here the opposite. And you integrate here by using the power rule for integral, going to be negative x cubed over 3 minus x squared over 2. You take it at -1 and at -2. From the second integral, you get almost the same thing. And when you calculate, the first bracket here, you guys can see when you subtract x by -1, you'll get -1 to the power 3, going to be -1. And with this minus sign, it becomes +1 over 3. And -1 is squared, going to be positive over 2, you get the second term. And this second bracket is obtained when you guys substitute x by -2. The third bracket is when you substitute, x by 1. And the fourth one is obtained when you substitute, x by -1. And after calculation, as you can see, you guys will get -1 over 6. Any question? Yeah. So here, yeah, because we have minus here. So we have minus. All right. So we have minus here, x cubed over 3. So when you subtract x by -1, you will get -1 to the power 3. Okay. So here, this is going to be -1, and with this minus sign, that's why it becomes 1. Right? Yeah. Okay. Any other question? All right. I'll take the solutions and all right, so I'll let you take the solution first, and then after that, I'm going to take his attendance before letting you go. It's 9:52. So we're supposed to finish at 9:50. Okay, you guys let me know whenever you're done taking the solutions, and I'll take the attendance and we'll let you go until tomorrow. So we'll finish it. So you guys are done?
Yes, Professor, I'm done.
Alamin, you done?
I'm also,
Yes, I'm done.
yeah, I'm also done.
Everybody has done?
Yes, sir.
All right. Okay, I'm gonna take the attendance before letting you go. And you guys can leave whenever you hear your name, say just you here, and then you can leave if you want. Okay. All right, Mangabet, I guess he's here. Yeah, thank you. Fatima,
Here.
thank you. Alamin,
I